Hello, everyone, and thank you for joining us today. My name is Patrick O'Brien, and today we will be looking at the question, should my initial cybersecurity risk assessment consider non-hackable protection? And so for our webinar today, we'll be using the GoToWebinar application. And so please make sure that you have your speaker enabled in all places. Your audio is muted for the microphone, so you won't be able to ask questions verbally, but you can ask them using the questions tool on the right side of your screen. And so if you have any questions throughout the presentation, or if you lose audio, please put those in the question chat, and we'll be able to review that and go through any of those questions. And we should have just about 20 minutes or so for questions at the end of the presentation, so we'll have time to talk through any comments then. Before we get started, I'd like to give just a brief introduction about myself and about Exida. So my name is Patrick O'Brien, and I'm a senior safety and cybersecurity engineer at Exida. I've been working at Exida for about 8 years now, and originally started out primarily on the functional and process safety side. So my background is in chemical engineering, and I've facilitated a number of HAZOPs for quite a few different industries, different units. And over time, as we kept working on the safety side, we saw that cybersecurity had the growing potential to cause a very significant impact. And so a little over 5 years ago now, we went ahead and developed our first cybersecurity book implementing IEC 62443, a pragmatic approach to cybersecurity. And so that really was where I started to transition and really deep diving into those cybersecurity aspects as well, and understanding what could go wrong if those critical control and safety systems aren't secured. And so we've continued to develop that approach of looking at both safety and cybersecurity. And last year, we partnered with the Center for Chemical Process Safety to develop a new CCPS concept book, Managing Cybersecurity in the Process Industry, a risk-based approach. And so we're very happy to continue developing and help share knowledge and move the industry forward as we try to tackle today's cybersecurity challenges. For Exida as a whole, we are a customer-focused company, and we help our customers to achieve safe, reliable, and secure solutions through a number of different areas. We were originally founded as a certification and assessment body who did functional safety certification against the IEC 62508 standard for safety logic solvers, final elements, and sensors for use in safety instrumented systems and functions. And over time, we've really seen that certification group grow and include a number of additional standards, including the ISA IEC 62443 standard series. And we're now one of the leading cybersecurity certification bodies for industrial control systems. Additionally, in addition to those certification activities, we also have a number of lifecycle services for functional safety, cybersecurity, and alarm management. And so we work directly with the plants across many different industries to help them tackle their safety, cybersecurity, and alarm management challenges. And when we talk about initial cybersecurity risk assessments, that's really a part of our lifecycle services that we help customers with. And then lastly, for our enterprise tools portion, our product group has a number of different software tools, including the Excellentia platform for functional safety, Excellentia Cyber, and then SIL Alarm for the alarm aspects. So we can really work with all of those different lifecycle areas from the tool side as well. And we have reference materials like our books and our templates that can be a helpful starting point for getting more involved and learning more about these areas. And so for our presentation today, we'll be focusing on really understanding what it is that an initial risk assessment is, when do we complete them, why are they important. We'll look at what are the most common methods that are being used for the initial risk assessment today? And then once we have that background, we'll really get to our starting question of whether or not those non-hackable protections should be considered and how we should look at those. And so for our first question, what is an initial cybersecurity risk assessment? This is something that was defined in the ISA IEC 62443 standard in part 3-2. And so that entire portion of the standard is focused all about cybersecurity risk assessment and broken up into multiple ZCRs or groupings of requirements. And so for ZCR1, it's all about getting the necessary system background information, having the inventory, the architecture diagram, and then the initial cybersecurity risk assessment is really where we start that risk assessment process. And the actual normative part of the standard, or the part that you have to comply to if you want to comply to the standard, is relatively short. It's just this one sentence here. And what it specifies is that the organization shall, so it's a must, perform a cybersecurity risk assessment of the system under consideration. And then the caveat is, or confirm a previous initial cyber risk assessment is still applicable. So there is an opportunity where if one had been done for a system in the past, you don't always necessarily need to do a completely new risk assessment. If you can demonstrate that it's still applicable, then you could apply that. But ultimately, the goal is to identify the worst case unmitigated cybersecurity risk that could result from the interference with, breach, or disruption of, or disablement of mission critical IACS operations. And so in addition to this one sentence here, there's another paragraph or two that provides a little bit more context on the background and some guidance to consider when completing that initial cybersecurity risk assessment. But if we think about what are the key points here, it's the start of the cyber risk assessment process. So initial, we can kind of get that idea of being at the starting point. It's our first pass through. And that other key part that is mentioned in the standard is that worst case unmitigated cybersecurity risk. So we want to understand what is the worst case consequence that could happen, how bad could a compromise be, because that's going to drive how much time we spend really analyzing it at a more detailed level, and also drive how many protections do we need to stack up, do we need to put in place. And by completing this initial risk assessment, we can really prioritize what those high-risk devices are, what those high-risk zones are, and then focus on them for the future studies and make sure that we are mitigating risk in the right areas, focusing on those highest risks first. And so as we go throughout this presentation, I apologize, I will switch back and forth between terms that I tend to use interchangeably, and that is initial or high-level risk assessment. And so originally in the 3-2 standard, when it was being developed, they called the first stage of the risk assessment the high-level risk assessment because it was looking at things at a higher level view. We weren't going to the same level of detail as a detailed risk assessment where we've got very specific threats and we look at countermeasures and protections. And so it was really meant to just be that higher level view of the system, identifying what the critical zones are. But during the process of finalizing and continuing to develop the standard, ultimately the switch was made to call it the initial risk assessment because it's that starting point where the risk assessment journey really gets kicked off. And I think that they had seen that there's the potential for some confusion if we think about network levels when we say high level, because someone from the outside looking in may think that we're talking about just doing a risk assessment on the high levels of the network, which would be our enterprise or business network, as opposed to it's really focused on the OT network, which are actually our lower levels in the Purdue reference model. So I think for some of those reasons, ultimately initial risk assessment was the term that was used. But I know that in some publications I still talk about it as high level risk assessment. mostly because it has, I'll say, some better acronyms. HLRA has a nice ring to it, but initial cybersecurity risk assessment can sometimes be a little bit more of a mouthful. If we look at mapping where this fits to the standard, we can think about similar to functional safety. We've got 3 stages of the life cycle. We start with an assess phase where we really want to understand what our assets are, how big is the risk that we're trying to mitigate. In the implement phase, we can look at applying the cybersecurity countermeasures and doing our validation testing to confirm that we're meeting our risk target to demonstrate that those countermeasures are effective. And then lastly, for the maintain phase, we can think about all of the work that goes into maintaining the security of the network over time, periodic patching, updating our antivirus or endpoint protection, ongoing monitoring using security information and event management systems, looking at SOCs who are specially designed to monitor security communications and drive emergency response. So there are a lot of different things that we can look at throughout the life cycle. And this initial risk assessment that we'll be talking about today really gets that started, looks at the scope of systems and identifying critical assets, building out those zones and conduits, so understanding our network segmentation, how to design our network architecture is going to be that first step in the process. And then from there, for those zones that we identify to be truly high risk that require further study, then the detailed risk assessment where we think about specific threat scenarios or the pathways in which either external agents or even internal mistakes or disgruntled employees could lead to compromise. So we'll think about all of those specific pathways and match up the countermeasures or the protections with those pathways. But before we go and really spend all of that time digging into the details, we want to make sure that we're focusing on the critical zones, and that's what our initial risk assessment does for us. And then from there, in some cases, we can even look at semi-quantitatively verifying whether or not we've met our risk targets through a security level verification approach, or we can do it quantitatively based on the foundational requirements in the 3-3 part of the standard. So we've got different options for really demonstrating that our proposed design is going to fully meet our risk and our security level targets. And so now that we have some background on what an initial risk assessment is, where it fits in the life cycle, what we're trying to accomplish with it, we can then look at what are some of the most common risk assessment methodologies that are being used today. And so the 2 that I see most often, and I'll say 99+% of companies that I've worked with who are either bringing us in to review previous work and provide feedback, or who are putting together a specification for an initial risk assessment, will use 1 or 2 of these methodologies. And so the first is a HAZOP-based methodology, where you start by really driving from the HAZOP scenarios first, looking at understanding, is the specific cause from the HAZOP hackable? So is it something that could be triggered from a configurable system by some sort of external or internal actor? And it'll also look at that question of, are there non-hackable safeguards to protect against that scenario or not? And ultimately, for those scenarios that we identify could be hackable, the SL target is specified for that zone based on the worst case consequence in the HAZOP that's been filtered. For the asset-based methodology, instead we start first with the network architecture, and we discuss what the possible compromises could be for each of the devices there. A lot of times we'll start with the DMZ or the demilitarized zone between the business and the OT networks as our highest point of consideration, and then work each of the network levels down to the level 1 equipment. And so for each of those devices, we'll talk about what the worst case consequence could be, and we'll then use that to do our consequence ranking and ultimately our security level targets. And when we get to those lower level control devices or say engineering workstations where we can modify configurations, we still want to and will leverage that HAZOP information and make sure that the consequence severities that we select are aligned with the HAZOP rankings for that system. And that helps us stay aligned between our safety and our cybersecurity activities. And so if we take a little bit of a deeper look at the typical HAZOP-based steps, this has been adapted from the original approach for completing this type of PHA or HAZOP-based methodology that was published by ISA in the book Security PHA Review for Consequence-Based Cybersecurity in 2019. And if we zoom in a little bit on kind of the key part we'll focus on today, this is looking at how we may filter scenarios from the HAZOP to identify whether or not they should apply to the cybersecurity risk assessment. And so there are three questions that we're going to ask, and that is the cause hackable? And if it's not hackable, then that would be something that we filter out from consideration. Typical non-hackable causes would be things like tank leaks or any sort of, physical damage like a tube leak in a heat exchanger. That would not be something that could be triggered from a compromise of the system. Whereas things that are control system failures or failures of automatic valves would be considered hackable. Next, we'll look at, are there any non-hackable safeguards? So those would be things like pressure relief valves, and we'll talk about the details of everything that would fall into that category a little bit later. And if there aren't, we can think, is it a scenario that really should have a non-hackable protection, or is it something where we're relying on instrumented safety functions and other things that are still configurable and could be potentially hackable? And so after we go through that filtering, we'll see, is it a scenario that we will assign a security level target based on the consequence, or is it something where we'll filter out of our security risk assessment? And so if we go through and just look at one example of using this approach, we've got a excerpt from a simplified HAZOP study where we look at a pressure control loop failing a valve full open and leading to either an overspeed or a potential overpressure of a downstream turbine. And so for our first question, is the cause hackable? Because we're talking about a pressure control loop, that is something that would be hackable. We could modify the configuration for that loop. We could modify set points and potentially cause this incident from a cybersecurity perspective. Then if we look at the next question, are there any non-hackable safeguards? For our first consequence for our T100 overspeed, we have an overspeed safety function identified, but again, this is a configurable, potentially hackable device. So for that first consequence, we would not have a non-hackable protection, and we don't have a non-hackable option for implementing overspeed. And so because of that, we're going to assign a security level target based on the consequence from our HAZOP. And so what that would mean is if we have something that is a safety consequence 5, for example, that may map over to security level 4. And so similar to safety integrity levels from the functional safety side, in the cybersecurity standards, there are 4 security levels, with 4 being the highest and 1 being the lowest amount of requirements. And we'll see that companies align their risk criteria where either based on the consequence or based on the risk score, that will correlate to a security level target. So they'll figure out how many protections they need to implement based on how critical the result of a compromise would be. And so that gives us our first example of the HAZOP-based methodology. If we look at the typical asset-based steps, here, we still need that PHA or that HAZOP information available as input. We still need our device inventory, but now we're really driving it more so from that asset-based approach, from that inventory and that architecture. And so for each device on our architecture, we're going to identify what the worst case scenario is. We'll talk through and facilitate a discussion to understand what would happen if the device fails. We have some sort of denial of service where we lose its function. And then we'll talk about a compromise case where what is the worst case scenario that someone could trigger intentionally trying to cause harm. And depending on how severe those consequences are, we'll determine our security level target for each of those devices, assuming a likelihood of 1. And that's something that's really important during our initial risk assessment, is we're not considering how likely it is for a given type of attack to occur. We're not taking credit for any cybersecurity protections like network segmentation or antivirus. We're really just trying to prioritize those most critical zones based on that worst case consequence. And then for those groups that, or for those devices that have similar risks, similar SL targets, we'll then group them together into zones. And for each of the zones, we'll identify what that initial response would be depending on how critical that zone is should a compromise occur. And so if we take a simple network architecture, when we go through and drive the asset-based approach, we'll talk about each of those devices. So for example, for our enterprise workstation, the consequence may be just loss of business functions, whereas the compromise of our engineering workstation could mean that we can modify our BPCS PLCs and overwrite the configuration, set unsafe set points, cause valves to open or close when they shouldn't. So we may have a very different operational impact that we see. And so here we can see an example of mapping those different consequences onto each of the devices in the network. From there, based on our risk criteria and based on how we map that to security levels, we'll identify a target for each of the devices and really use that to guide our network segmentation strategy. And so here, for example, we may look at establishing a demilitarized zone, so separating out our enterprise network, making sure that we've got our critical servers in a DMZ. And then we may look at, do we need to have separate control and safety zones based on our risk rankings and based on how our network is set up. And so that would be a simple example walking through the asset-based approach. And so now we come to our driving question for today's webinar. Should I consider non-hackable protections when going through and doing my initial risk assessment? And so to start, it's helpful to get a little bit of a better definition of what those non-hackable protections are. And so when we look at what we would consider to be hackable protections, these would be things like our control system alarms, any sort of BPCS protection loops, any sort of safety instrumented system, basically anything that's got a processor that we can configure, a USB connection or a network connection. All of those would indicate a potentially hackable device that we would not be able to take any credit for at this stage of the initial risk assessment. For non-hackable devices, these would be mechanical devices like pressure relief valves, rupture discs, sometimes slam shut valves for high flow conditions. It would also be things like dikes or bunds. So if we have a physical barrier or wall to prevent a leak or loss of containment from spreading, that would be something that we could consider for reducing our environmental impact. So that would be something that we can look at. Now, the last one I have here becomes a little bit more of a gray area and is often a point of discussion, and that is hardwired relays. And so, if we have a relay that is, not connected to the network, it's not a smart relay, it's not configurable, and we have hardwired safety functions in it, then we may be able to consider that as a non-hackable protection. But what we're seeing today is many of these relays are being replaced with smart protection relays, which would be hackable, and so we wouldn't be able to take any credit for them at this stage of the risk assessment. And so if we think about how does each method handle non-hackable protections, From a HAZOP-based approach, they're clearly an important part of the method. And really, not only are non-hackable protections considered, but if a non-hackable countermeasure is demonstrated, that'll actually filter that scenario from the HAZOP out from further consideration in the security risk assessment. So if we have an overpressure scenario in our HAZOP, but we've got a mechanical pressure relief valve, if we strictly follow that HAZOP-based approach, we won't even move that scenario over to our cyber risk assessment, and we'll just identify that for that scenario, there's no special cybersecurity requirements, just follow traditional cybersecurity measures for the zone. But on the asset-based side, this is something that I've actually seen vary a bit facilitator to facilitator, company to company. And so in some cases, the facilitator will make a decision to disregard all protections during the risk assessment. So not only are they not looking at hackable protections or cyber countermeasures, which would be true of all methods, that we're not going to credit those during the initial risk assessment, but they may also not look at the non-hackable protections as well and say they're going to do it just purely from a consequence perspective. Where other times, and typically when I drive an asset-based approach, I will allow non-hackable protections to be considered as long as we can show the evidence that they're in use, whether it's looking at the HAZOP to show that they've been considered and credited, and then we can apply similar levels of risk reduction to the HAZOP for it. And so if we think about the pros and cons and what is really riding on this decision of whether or not to consider them, the advantages are that we can incorporate non-hackable protections earlier in the process. And this means that we can really get a better understanding of the risk earlier in the process. And it saves us from potentially going down and doing a very detailed dive on a zone because it has a high consequence, to then find out that it's got a number of non-hackable protections that actually bring the risk of a cybersecurity event to be relatively low. So instead, we want to make sure that we are aligning our cyber approach with our functional safety, our PHA, and our HAZOP approach early, so that we are truly focusing on the highest cyber risk and making the best use of our time. Now, the disadvantage, and the main reason I've seen some facilitators who don't allow the consideration of non-hackable protections, is that it does take some additional time to evaluate them and really do a good job of going through and making sure that if we credit them, that they are appropriate and effective for that scenario. And the reason it takes additional time is it brings a couple other discussion points into view. So we can talk about, well, how effective does a non-hackable protection need to be for us to consider it? Because again, if we think about the HAZOP-based methodology, we're potentially filtering that entire scenario out of consideration just for having that non-hackable protection. Typically a mechanical PSV, that's a reliable device. We can get 2 orders of magnitude from it during a functional safety risk assessment. So if we take that level of credit, then we may say, okay, that's enough to filter that out of the cyber consideration. But what about if we have a hardwired relay? Is a SIL 2 relay, would we filter it out because we've got similar reliability to a mechanical PSV? What if it's only a SIL 1 relay? That's something that we're saying is going to potentially fail really 1 out of 10 times on the band. Is that something that we're going to say is reliable enough to completely remove that scenario from further cybersecurity consideration? And then other points that can get brought up are, well, what if the protection wasn't designed for a cybersecurity scenario? So even for a mechanical PSV that's a very reliable device, it has a set capacity. And so if it's possible for an attacker to really, let's say, open multiple valves, cause something that we would consider maybe a double jeopardy scenario in a HAZOP because there are multiple control loops, multiple valves failing, can they overwhelm that PSV and create a condition that the site and its protections weren't designed for? In that case, that mechanical PSV may not be enough to help you from an overpressure. And then another one would be, what if the protection changes in the future. What if we replace a legacy relay that was non-configurable, non-hackable, with a smart protection relay in the future? Certainly we would expect to go through our functional safety management of change and make sure that we're achieving our same SIL target, that it's a reliable device. But would that always trigger a cybersecurity management of change? Would we reevaluate and revalidate that cyber risk assessment every time we make a change to a relay? And in many cases, the answer to that is no. It's not something that we have to be aware of to make sure that we understand the potential change that could have on cybersecurity. And so when we get kind of caught in this debate of method of deciding which approach to take, whether or not to consider them, there's a quote that I heard quite a few years back in an English class, actually, that's always stuck with me. And it's something that I try to go back to whenever I'm looking at multiple methodologies, trying to understand what's the best approach for a given application. And although a lot of times we are debating, between two choices, thinking it has to either be A or B, it's more often, both A and B or neither A nor B. So, we kind of limit ourselves to two choices and may miss what's both and what's most important. So, for example, maybe instead of picking between either doing a HAZOP-based approach or an asset-based approach, maybe we need to do both and look at what can we pull from each of those methods. And in terms of should we apply non-hackable protections in either HAZOP or asset-based, maybe there are going to be certain protections that we would want to apply to both of them and certain ones that aren't effective that actually shouldn't be considered in either. So we should use them in neither of the approaches. And so with that in mind, what I'll propose is food for thought or as consideration in our webinar today is to think about taking a hybrid approach. And so we've done a little bit of color coding here where things that are really following that PHA or that HAZOP-based approach are in red, things that are following the more asset-based approach are in yellow, and then our hybrid where we merge those two methodologies together, we're showing in orange. And so our inputs and our outputs from the assessment are still the same, but we take a little bit of a different process to get there. So we start by filtering the consequence scenarios in the PHA, just looking at what are the highest consequence events from the PHA. And one thing that I've seen as a drawback if we rigorously apply the HAZOP-based methodology is that some organizations want to go through and do that filtering for every single HAZOP scenario. But when we look at larger sites, there may be thousands and thousands of pages of a HAZOP report where going through each line individually may not be the best use of the group's time. Instead, if we do some filtering and let's say just look at the highest consequence severity, see if there are any hackable causes, and then if there aren't or if there are but they have protections, we can bring those over and then go down to the next consequence severity and again see are there any hackable causes. And that's going to help us focus on just those worst case scenarios that are going to really drive the risk. The next piece that we should consider is when we find non-hackable protections from the PHA in this method, instead of fully removing that from consideration and not looking at that scenario, let's go ahead and let's bring that protection over and list it as a non-hackable protection in our cyber risk assessment. And we'll keep visibility for it. In terms of likelihood reduction, we're always going to start at that highest likelihood of 1, but take the same amount of credit or risk reduction as we did in the PHA. So for our pressure relief valve, if we determine it's effective, we could drop from that highest level down 2 orders of magnitude or 2 likelihood levels and make our evaluation from there. And then after we've done that and brought those over for the devices in the HAZOP, we still want to make sure that we're going through our network architecture, that we map those consequences to the devices where they can occur, and also that we are understanding what could happen from devices higher up in the network. So, what can we do from an engineering workstation versus from an HMI? What servers are in place that could potentially write to lower level devices? We want to understand all of those questions about the network. We also want to think about, in addition to the compromise scenarios, what would happen if we lose the functionality of that device, and that'll give us a more robust picture of how critical each device is on the network. From there, once we have all our consequences defined, we'll then identify our security level target based on either our consequence severity or based on our starting likelihood of 1 and any risk reduction from non-hackable protections that can be applied. And then from there, we've got a full picture of the risk, and we can group those devices into zones, recommend segmentation on our network architecture, and really use that to drive our approach forward. And so if we consider this method, we can talk about, well, what are the benefits for taking that hybrid approach? The first one is that we're able to clearly identify what non-hackable protections were considered, document any assumptions or the information that we had at them for the time of the study, and make sure that we validate any assumptions, and that in the future, if any of those protections are changed, we now have a clear link back to where they were considered in the cyber risk assessment. Another thing is that by combining the approaches together, we can actually take what works best from both methods and apply them to our application. And I've seen that can let us move faster than, let's say, doing one approach fully and then another down the line. And really, we get a lot more momentum and are able to drive that assessment of the system in a more effective way. And then we can also make sure, because we're looking at the non-hackable protections up front, we make sure that we're really getting a full risk perspective from a cyber standpoint to understand which of the zones are most critical. And I've seen a number of times that although an overpressure scenario may be, the highest consequence severity in a HAZOP, there may be, let's say, a high temperature or a low temperature embrittlement scenario that is, one consequence severity lower, but because it doesn't have non-hackable protections, ultimately has a higher cybersecurity risk. So it really lets us figure that out and understand how critical each of our zones are up front. And so that, again, moves us forward. It gets us off on the best start for our cybersecurity risk assessment process. And so in summary today, we talked about what the initial risk assessment is and the common methods for it. Then we looked at whether or not non-hackable protection should be considered and the potential benefits of really letting us know our cyber risk up front and focusing on the most critical areas when implementing mitigations and when doing future activities. And so it really does get us kickstarted and get us moving on that journey to making a more secure system and a more secure and safe site. And so I've seen a couple of questions that have started to come through. And so please don't hesitate to add in any more questions as I go through the last couple of slides. So one of the things that I always like to highlight at the end of training is that we have in the exida Academy a lot of really great training options to consider, and these range not just from functional safety, but through cybersecurity and alarm management as well. And we've got a number of updated or new courses. We've got this FSE 001 course that is an introduction to functional safety, and that is a really good high-level primer for people who are just getting started trying to understand what functional safety is all about. We've got a new recording of the FSE 110 Machine Functional Safety Engineering course that is fully revamped to look at the latest version of IEC 62061 and also splits out some of our different machinery standards. So that is a good course if you are coming at things more from the machinery side of things. And we've got updates to our FSE 211 and our FSE 242 courses as well. On the alarm and cyber side, We've got updates to our Alarm 102, our CS 101 and CS 102 courses, which are the two halves of our CS 101 course, as well as some significant updates to our integrator and solution provider course. And then in terms of instructor-led live courses, we've got upcoming courses for a variety of functional safety and cybersecurity courses, and an upcoming in-person live course in Sellersville in December for the FSE 100 course. And then lastly, in terms of how can exida help, so there are a number of ways in which we are actively working with customer to tackle cybersecurity issues. As I mentioned, we've got consulting lifecycle services, so everything from actually facilitating the risk assessments ourselves to providing review and advisory guidance on risk mitigation strategies. We're heavily involved in vulnerability testing, developing cybersecurity programs. So there are a lot of areas where we can really help companies get started if they are looking to tackle cybersecurity questions. We've got certification options both for development processes, components, systems, and sites, as well as for individuals looking to get cybersecurity certification. As I mentioned, we've got a lot of great training courses for learning more. We've got tools like Excellent to Cyber for actually doing the risk assessment, and a number of reference material like the Implementing IEC 62443 book, as well as templates focused for each part of the standard. So whether you're an asset owner, a system integrator, or a component developer, we've got templates developed for the parts of the IEC 62443 standard that you need to worry about. And so if you enjoyed this topic and are interested in learning more, please don't hesitate to follow exida on social media, as well as if you are interested in continuing this conversation, don't hesitate to send me an email or connect on LinkedIn. I'm always happy to keep the discussion going and talk more about cybersecurity or functional safety.